hello, hello. Hello. Shut up. Okay. Okay. What is up, chat? Today's day 2 out of 7 until freedom. It is 8 p.m. right now. I plan to sleep for 5 hours, so we're sleeping at 5 at 1 today. Some, as you can see in chat, not like yesterday. Yes, let's do some math. Oh yeah, history. History went quite okay. The last question was a bit niche, not niche, niche. Talked about the Black American education, like hasn't made any progress or not. I said it did. So, let me know down if you guys did pick that it did make progress. Oops, that's not ideal. There we go. I got myself some chips. It's coming through the revision session today. Absolutely beautiful. Okay, today's plan. See from here. Oh, that's the wrong one. Ugh. Not nice at all. Go. Scene 3 here. So as you can see, we got a past paper here. What am I looking at? Which camera? Alright, we need to look at this one. What we have is a past paper or booklet here to do my workings out. Plan is to do a timed session. I think honestly 1:45 for an exam. Given that. Oh shit! Is it working? Hello, hello, hello. Chicken nuggets. Chicken nuggets. It works. It works. It works. Okay, so it's still on the audio. If I go here, and there's the headset. All right, hello, 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 hello. Good. All right, yeah, it works. So like chicken nuggets, just testing the mic. Works. Okay. Before we just get started, I'm gonna just show you a black screen for the next 5 minutes. Just quickly set myself up, and after that, yeah, we'll get started. See you later, guys, in 5 minutes. Okay, we are back. We finally done it. Seeing that 5 minute break, I didn't even. Dude, read it. Of course. Yeah. Pen, calculator, my calculator, ruler, compass, pencil, pencils. Shit. What else? Don't know if you guys can hear the audio well. Oh, you guys. Then, oh yes, green pen. Alright, so today we're going to be doing past paper. Like I said before, we're doing this on the beloved Dr. Frost. Now, Dr. Frost, it's like the teacher that you want, but you don't want at the same time. You answer a question. Oh my god, the glare is crazy. Alright, you answer a question. Alright, teacher comes from halfway of the room. Takes some time. Maybe goes to a couple more students on the way. Then she marks it. Oh no, that's wrong. She doesn't show how you do it. Dr. Frost, on the other hand, all right, you can throw papers, mess about. It won't give a shit, honestly. But as soon as you get a question wrong, like that, marks it quickly, and you don't know where you went wrong. Fair enough. Math is hard. But then you have like a little video there, as you can see here. It's a little video. Very nice. Can't notice if I'm delayed or not. Input latency is crazy. So yeah, we're gonna just Alexa, start a 1 hour and 30-minute timer.
Second timer, 1 hour and 30 minutes, starting now.
Let's go, guys. Turn up the brightness. All right, here we go. Yeah. Let's go. Okay, Beth completes some jigsaw puzzles and records the following information, number of pieces in the jigsaw puzzle. Okay, the time to take the jigsaw puzzle in minutes. Let's show this information on the scatter diagram. 3,000 piece. 3,000 piece jigsaw puzzle takes 460 minutes. 3,000 piece jigsaw puzzle takes 320 minutes. So this information on a scatter diagram. Okay, this is, I have to get closer a bit. There we go. So, 3,000 pieces. 460 minutes. Whoa, that's loud. Ooh. 3,000. Go up a bit. There's like 1, 2, 3, 4, 5. Split in 20s. 460. 1, 2, 3. No, it's split in 25. What am I doing? 25, 50. It's around here. And then 3,000, 1,300, 1,200, just in the midway here. Go up to 320 minutes, which is just below there, like that. So let's see. See, instantly marks it. Where's my equipment? I didn't even write anything. I didn't even need to write anything down. That's how good it is. Bed completes some jigsaw puzzles. Yeah, same thing. Best shows this information in the scatter diagram. Describe the type of correlation showed on the scatter diagram. Oh, that's positive correlation. Oh my god, if you're getting this wrong, you are genuinely a dickhead. Beth, not dickhead, sorry, a nonce. Not nonce, sorry, that's. I'm trying to think of a funny word that describes stupid people. You're stupid. that suffices. That combines complete some jigsaw puzzles and records the following information: number of pieces in the jigsaw puzzle, time taken to complete jigsaw puzzle in numbers. So, one of the best jigsaw puzzles was described as the most difficult jigsaw puzzle you will ever try. Give a reason why you chose this jigsaw puzzle. It's like the most likely puzzle on Sky Diagrams. Give a reason why you chose that. Jigsaw puzzle. So it's like 4,600 pieces that took. Oh, it's definitely C. So many pieces and took no. The, so this has the most pieces, but it happened under that minute. It's C. All right. There's like 600 something. 600-ish minutes in like, which is like 4,500 with 4,500 pieces. A, no, no. Oh, A. It's not definitely not A. I'm gonna say C. C because it took a long time and the highest number of pieces. No. C because it has no. Oh. No, C because it has the highest number of pieces. The highest number of pieces is like more resolution. You know what I mean? So like, yeah. Oh, that's incorrect. That's no problem. We get to try again. So we now know it's not C. I'm an idiot. Why did I? It's not the highest number. Oh, you idiot. Alright, so it's basically B because it took no, it didn't take the longest time. No, it has lots of pieces. It's not A, it's B. It took the longest time. B because it took the longest time, but has the fewest pieces. No, it doesn't have the fewest pieces. It has a small number of pieces. No, 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 no. No, it's definitely this then. Because it took a long time and has the highest number of pieces. Yeah, it's that one. What? That's just B because it took the longest time, but has longest time. What do you? I can't read a graph. Yo, I can't go in the exam tomorrow like this. How can I not read a graph? How can I not read it? All right, we move on. Uh, I was gonna say that for a revision later, but I'm not gonna do it now. Alright, Beth completes some jigsaw puzzles and records the following information. Number of pieces in the jigsaw. Oh, same shit. Beth shows the information in the sky diagram. Draw a line of best fit on the diagram. Well, that's obviously C. Correct. Okay. Beth completes some jigsaw puzzles and records the following information: number of pieces in a jigsaw puzzle, time taken to complete the jigsaw puzzle in minutes. Beth shows this information on the sky diagram. This guy is an outlier right here. Look at that. He's on best fit to estimate how many people in a jigsaw puzzle that takes Beth 500 minutes to complete. Ooh, 500 minutes. Go down and all the way down. Takes. Is it this line or that line? Shit. All right. Let's try again. 500 puzzles. We go down. So it's second one down. It's 3,200. Oh, wrong camera. Okay. Yeah. Okay. Explain why Beth should not use her sky diagram to estimate how long it will take to complete a jigsaw puzzle containing 8,000 pieces. Yeah, 8,000 pieces is beyond the data. We still haven't wrote anything, by the way. This is all on the computer. Restaurant has 4 main courses. Finally, we managed to get to write something. Oh, for the meal, each customer should do 1 main course and 1 side dish. Work out the percentage of possible meals that cost less than 8 quid. Hmm. So less than 8 quid. So 5 plus 1 times 5 plus 2. So I think what we're working with here, we're working with product rule. So if we're doing product rule, then yeah. Oh my god, there is a person on the stream. Let's go. I hope you are doing GCSEs too. Okay, if you can help me out, drop a message in chat, you know what I mean? I'm lonely. I'm lonely. I'm lonely. Anyway, come on. Lock in. So 5 plus 1 times 5 plus 2. What am I doing? 6 times 7. 6 times 7 times 5. What else? Times 7 times. I don't think 8 includes it. 6 times 7 times 7. Which gives you 6, 294. And then we have to do like everything multiplied by everything. 6 times 2 times 3 times 1 times 7 times 3 times. No. 6 times 2 times 3 times 1. We have to add these together, I'm pretty sure. Plus 7 times 2 times 3 times 1. Oi! What the hell? My iPad just shut down. How'd that happen? How's it's connected to the computer. It'll probably work like that, you can see. What the hell? Okay, Kevin, what do you mean very low? What's wrong with my power outage? Not power outage, what's wrong with my power plug? What's wrong? Okay, I've got an idea. We can fix this. We can easily fix this. Just gotta add the freaking. Let me just quickly fix this bad boy. No. Your SV device. No. Ugh. Deactivate? No. Device resolution type? No. Okay. Video capture. What about scene 2? This is video capture. Weirdo. Okay, that is just. I mean, do we need video capture? Scene 4 is also black. Oh. Oh, I just broke the system. Oh. Oh, back. Ooh, phew. Are you charging when yeah, you are. Then how do you break? How? Okay. Video capture device. Device 2. It's not USB to video. Scott. Alright, guys, I think I just have to continue with me, not just like turning on the camera just yet, guys. Yeah, it's sad you won't be able to see my face, but you know. Oh wait, I won't be able to even see the chat. I've got an idea. Oh, you guys can see that. And then only been live for 20 minutes, guys. Come on. I'm pissed. Okay. Dude. How? Okay, Fez. Okay, restaurant menu has 4 main courses. Where was I? Okay, 6 times 7 times 7 equals 294. And I done. 8 times 2 times 3 times 1 plus 7 times 2 times 3 times 1 plus 5 times 3 times 2 times 1 plus oh, another 6. 6 times 3 times 2 times 1. Okay, that should get us 144. What? Yep. 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 Oh, we have to times these together. It's not million. What? We got percentage of possible meal that costs less than £8. Once here. 1632. 294 out of freaking 1,632,960. I don't know where I got that answer from. Okay, that's not very nice. We do. I'm gonna store that as A over times by 100. That's so wrong. Like, not only that looks wrong, it's just wrong. I got 0.018. So it's basically 0. No. Okay. Try that again. Hmm? Alright. I think we can now probably shut this down because we got the iPad back up. Next to screen. Safari. Okay. Any moment now. Come on. Come on. Anything? Guys? Dude, what about here? What are we looking at? Out. And there we go. Allow. Oh, there we go. Oh, yeah. Okay, we should now be back. Hey! Alright, we're back. Okay. Oh, what the hell happened there? Okay, so we are now Janine back now. All we gotta do is do this. Bap. Bada bap boom. Pow. Okay. It's 3-2-0. That is horrible. Ugh, why is it laggy? Ugh. Okay. Cozy P is alive. What a guy. Alright. No way. Oh my god, it just turned off again. Seriously? Why is it doing this? Stupid. Alright. Alexa, pause the timer.
1 hour and 30-minute timer paused.
I'll be right back, guys. Just Okay, so I just got a new cable. Everything should be fine now in a couple of minutes. Alright, Alexa, continue timer.
You have two pause timers on ORB of Endless Chaos, a 1 hour timer with about 59 minutes and 56 seconds left, and a 1 hour, 30-minute timer with about 1 hour, 12 minutes and 19 seconds left. Which one do you want to resume?
Second option.
Your 1 hour, 30-minute timer resumed with about 1 hour and 12 minutes left.
Get in. Okay, let's go. We are back, ladies and gentlemen. Okay, it doesn't matter now. Do this. Okay, what do you mean? Okay. Seems like we're not doing enough now. Scratch this. Restaurant menu has 4 main dish courses and 3 main dishes for the meal. Each customer chooses one main course. Work out the percentage of possible meals that cost less than £8. 6 times 2 times 7 times 3 times 5 times 6 times 1 equals 6 times 2 times 7 times 3 times 5 times 6 times 1 equals 7560, and then we do the meals that cost under, so 5 times 1 times 6 times 2 times 3, 5 times 1 times 6 times 2 times 3, 180, 180 over 7560 times by 100. Get us a percentage, 180 over 7560 times by 100. 2.4%. Wrong. Okay. At that point, we should be watching the video. Oh my god, that was loud. Wow. Okay. Now that we have a supply of endless charge. Wow, that is loud. Oh, don't start. Refresh. Show my camera. Allow. Okay, there we go. We're back. We are back now. Full motion. This. Phoenix. No, don't turn off. Phoenix, the pepper wait and stay. Go. Okay, there we go. Hopefully mic is testing ready. No, where's it? Just want to see if it makes a sound. All right. Bombaclat. Let's go. Here we go. Where were we? Ah, yes. 543. So 2060, 160 over 125. Yep. Okay. So for the meal, each customer chooses one main course and one side dish. Work out the percentage of possible meals that cost less than £8. It even works. It does. Give you answer to. So I got 2.4% here. Let's try this again. 7. For the meal, each customer chooses one main course and one side dish. Work out the possible meal that costs less than £8. So there's you can have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can have 12. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can have 12 combinations in total. So you have 12 potential meal choices that, okay, which leads to, I don't get this. It's out of 12. So what adds up less than 8? So 5 and 1. So 1, 2. So 2 plus, so 5 and 1 and 5 and 2 and 6 and 1. So 3. So 3, which get, and you divide that by 4. 3, 1, 4. It's going to be 20%. 33.3%. What? Okay, for their number combination, their number of meals. So for BG, so beef burger and garlic bread, £7 versus £7 VG burger and garlic bread, and then turkey stew and garlic bread. So the 8's also considered. So 4 times 3 is 12, but 4 over. Oh, I need one more. I see. Still a topic I'll come back to anyway. So yeah. Okay. Write these numbers in order of size, starting with the smallest. Lovely. Starting with the smallest. So 0.36, and then we have 1 over 333. Wait, we could. It's not calculated paper. We can over 333, which is 0.003. We have 0.03 and 3.1 times 10 minus 3, which is 0.0031. 0.0031. So the biggest out of all of this is 0.36 first, then it's 0, then it's going to be, I'll start with the smallest, sorry. So it's going to be 1 over 333. That's the smallest, and then 0.0031, 0.03, and 0.36. 0.036. 0.36, sorry. So this first, this second, this first,
This. Oh, yeah, that's right. Am I okay? Or is it the other way around? Where's starting with the smallest? Yeah. Hold on. 1 over 333 is 0.003. Okay. Then 3.1 times 10 to the power of minus 3. 0.0031. Yeah. 0.03 and the 0.36. This is 36%? Yeah. Percent. Less than 1. 36. Divide by 100. 0.0036. Oh. So it's actually this. It's this bigger than that. Yeah, okay. That was smart, you know. That threw me off completely. Okay, okay. KC Mobile's phone gives a weekly report showing the amount of time they use their phone. Siri, no sir. Alexa, show me how much time is left.
Here are your timers.
Gee. Okay, we have an hour left. We've only done 9 questions. Sparkling water. You know, a good guy, friend of mine recommended me this. It's from Aldi. It's normal water, but with carbon, it makes you like. It's like more delicious in some sense, even though it's sparkling. But so it's 24 more. Ah, I see. So 217 times divide by 1.24. I've done this today, this morning actually, for revision. 175. Yeah, nice, easy reverse percentages question. Just gotta mark the rest correct so far. Oi. Alright, question 10 now. We are a third of the way through. A sheet of A4 paper card weighs 1.19 times 10 to the minus 2. Work out the weight of 500 sheets of paper. Nice and easy. 1.19, 10 minus 2. 0.0119. So we're doing 500 times 0.0119 equals 500 times 0.0119 gives you 5.95 kilograms. 5.95 kilograms. That's just nice and easy. Okay. The sheet of A4 card. Card is classified as W. The weight in grams per square meter. Sheet of A4 file is rectangle that is 21 centimeters by 29.7. Calculate W for this area card. I see. Okay. So we know that it's 0.019 over the area, which is 21 times 29.7. 21 times 29.7. 623.7. Weight in grams. You know what these guys are trying to do, but you know what I mean. Weight in grams per square meter. Don't know. 0.019. 119. Shut up. 119. 623.7. I guess you. This is weird, bro. No, I don't get this. Hold on. New page. W equals weight area. Area in square meters. Seriously? Okay. So 21 times 29.7 is equal to 21 times 29.7, 623.7. Divide that bad boy by 100, which gets you 1, 2. That's a 1, 2. So 6.237. Yeah, that seems about right. And then we do. Am I tweaking? Am I tweaking? Do 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 do. Square meters. I think we need like multiple. Hold on. 21 divided by 100. 0.21 times 0.297, which gets you 0.21 times 0.297. Aha! 0.06237. Weight is 0.0119 over 0.06237 equals 0.0119 over 0.06237. 0.19. Surely. This is not correct. I'm gonna. How? What? Grams. Wait, this is in kilograms. We divide by 1,000. kg. And then we have to divide by 1,000. 0.19 times 1,000. Sorry, we have to times by 1,000 for that. Equals 190 grams. Not 190.7? 6237. 119. What? How does that work? 1.197 times 10 minus 2 times 1,000. 11.9. 0.21 times 0.297, which is 0.06237. 109. Oh! Then we have to wait. Okay, we can give marks, but it won't matter now because we got it wrong. Alright, area of this triangle can be written as ax squared times bx minus 10. This question 12. I like area questions. They're nice. And the values of a, b, and c. Oh. So x plus c multiplied by 3x plus 2 x plus c 3x plus 2 minus 10 3x squared 3x squared plus 2x plus 3xc plus 2c minus 10. Weird. Find the values of a, b, and c. Oh, so weird. Ax squared plus bx minus 10. How many questions is there? 34. So we're not even halfway done, and oh my god, 39. Okay, come on, lock in. Oh, I got it. X equals ax squared plus bx minus 10. What am I doing? Come on. Wait, this is easy. Ax squared plus bx minus 10. Okay. It's not easy. I'm stuck. I'm genuinely stuck. Genuinely stuck. Okay. Okay, let's try now. Okay. B is what? Minus 10. Maybe C is 1.5. X is 1.5 actually. A, C, now we need B. B equals. B is minus 13 now, we know that. Now if we just. A is 3. B is minus 15, and C is 3x squared minus 13x. One by 5. Dude, what is it? So A equals 13 minus 13. Yeah, okay. What? And C equals minus 5? Weird. So weird. Okay, that's on the revision list. Okay, I cannot see anything. I have to turn off the light. Oh, we're back. It's getting way more talking. Oops. Function machines. Look at the value of K. Oh, wow. Okay. Function A input 5 is input into function A. 5 is also input into function B. The output of function A is 10 times the output of function B. Work out the value. Okay. So 5 times K plus 21 equals 5K plus 21. 5 minus 1.5 times K equals 3.7, 2.7, 3.7, 3.5. 5K. The output function A is 10 times bigger than function B, work at the value of K. So 5K plus 21 equals 3.5 times 10, which is 35K. 5K plus 21 equals 35K. Okay. Plus 21 equals 35K minus 5K. 21 equals 30K. K equals, hold on. 1.43? Weird. Okay, again. Let's watch the freaking thing video again. It's not what? Okay. Alright, so here are two functions. 5 is input into function A, 5 is also input into function B. Output function A is 10 times bigger output function B. 1.5k equals 10 times bigger. So 50k plus 210 minus 210 plus 1.5k equals 50k. We do 50 divided by 1.5, 83 recurring. No, that's not correct. So 5k plus 21 a equals, and then 5 minus 1.5, 3.5, yeah, 3.5k. B. Output function A is 10 times the output of function B. So 5k plus 21 equals 0.35k. 5k plus 21 minus 35k equals 0. 4.65k equals minus 21. K is equal to 21 divided by 4.65 minus 4.516. 4.516? That is not what? 0. How? By equation 5k plus 21 and 10, 5 minus 1.5. K. 5k plus 21. Okay. 5 minus 1.5. K. So that's 3.5. So 8k plus 21. As final answer. 140 over 31. Who? How did you get 140? What? 30k. Was it 21 over 30? 21 over Shit. Drop my pen. I found it. Go on. Alright, question 14. Diagram shows four triangles are joined together. A, B, C, D, A, B, C, and D lie on a straight line. Okay, show the triangle CEF is a right angle triangle. CEF. Ow. Okay, if we order the steps of corresponding reasons after each step. So angle BCF equals 30 degrees because angle BCF is isosceles and angle in the triangle are to 180. ABF is 60. Step 1. Step 1 angle ABF is 60 degrees because angles on a straight line like ABC add up to 180. Step 2. Angle FBC is 120 because angles on a straight line on the straight line BCD add up to BCF. BCF angles on a straight line. BC because angles in the equation ABF are equal. FBC, FBC, BAF, FBC, BAF. That's isosceles because angles. Okay, triangle BCF is a FCB, FCB, FC. Yep, angle triangle at 80. 3 BCF, BCF, BC. So the angle there. FBC 120. Because angles are in the equilateral triangle equal. Okay, step 3 angle FCE is 90. Step 4 with angles in the equilateral triangle CD all equal. Angle BCF, BC 30 with angles on a straight line. Because angles in the equilateral triangle, no, because angles on the straight line ABC at no. Step 5, step 4, because yep, that's right. Step 5 angle FC is 90 degrees. FCE 90 degrees. ABC BCD BCE, and this goes there. Wrong. Okay. So angle ABF equals 60 degrees. ABF 60 degrees, equilateral triangle. Triangle ABF and CD are equilateral triangles. BCF is an isosceles. With BF equals BC, BF equals BC, BF equals BC. Yeah, same. So step 1, angle ABF equals 60 degrees because angle in equals triangle BAF are all equal. Step 2, angle FCB equals 120 degrees. Oh no, that's wrong. This needs to go here, and that needs to go like that. There we go. Now it's correct. There we go. Large box of chocolates contain dark milk, and white chocolate. When Riley opens the box, the ratio of dark to milk to white chocolate is 3:4. Each six of the dark chocolates, none of the milk chocolates, and all the white chocolates. The ratio of dark to milk chocolates is now 9:8. How much white chocolate did the 9 Riley family eat? First of all, what a bunch of fat people. You're not eating all the chocolate by yourself, let alone your. No, sorry. Joke didn't work out. Keep going. So dark milk, white, 3:4. The milk ones and all of the white. Ratio. Okay. 9:8. Dark to milk now. There's 9:8. So we have times by 3, times everything on top by 3, leaving E6 of dark chocolate. Ratio is 9:8. And we're down to 3. So 9:8. And we have to add 3 onto that. So 12. No, I have to times that by 3, which is 6. That stays the same. By 3, which is 12. As 12? That's so wrong. Surely that's wrong. Why is it pausing? Don't give me a heart attack, you little piece of shit. Almost said it. Almost said it. Video time. Hmm? Okay, so it's basic algebra up to that point. So let's try this now. Detective Conan mode, bro. Only OGs know who he is, you know what I mean? Alright, so when Riley opens the box, dark milk to white. Okay, I'm being very honest. Alexa, how much time is left of the 1 hour 30-minute timer?
About 21 minutes left.
I'm not finishing that in 21 minutes. So we're gonna do this final question and then gonna have to switch to talk to the topics. Oh shit. Okay, let's go. DM 3, 2, 4. 9 to 8, 0. So then it'll be 3x 2 equals 4, 9, 8, 0. So 2x plus x plus x over 3 equals 8 over 9. 4x over 3 equals 8 over 9. 24, 36x. 36 over 24. X equals 1.5. Okay, how many white chocolate pieces were there? So 4 times 1.5 equals 6. What? What the fudge is this? Okay. Okay, at least 3p, 2p, where p is bigger than 1. Okay, yeah, this, alright, we'll do some questions. X and y related by equation xy equals 36. Second correct statement, y is directly proportional to x. Okay, bro. Y is not proportional to x. Y is inversely what? How? How? Y is inversely proportional to x to the power of 4. Y equals, oh god, not this. Okay. Y inversely proportional to k over x for 2.5 equals k over 2 to the power of 4, which is 16. 16 times 2.5, which is 40. K is 40. Y is proportional. Y is proportional to 40 over x to the power of 4. Y equals 40 power of x, x 4. Oh yeah, colon shows a colon root has a radius 8 and height of 10. Look at the cone. The volume of the cone is equal to the volume of the cube. Look at the length of one side of the cube. Okay, so question 18. How many marks? 4 marks. V equals 1, 3 times pi times the radius, which is 8 squared times 10, which gets you third times pi times 64 times 10. 6403 pi. That gets you the volume. Volume of the look at the length of one side of the cube, and then we have to power of 3, which gets you 640 over 3 pi. 8.75. 8.75. Doesn't give, it actually like goes on, but we just, going on a tangent right now. Cafe owner, okay. Question 19. Cafe owner recorded information about customer orders for coffee. They recorded whether the customer asked for milk and whether they asked for sugar. The results are shown in this Venn diagram. One of the customers is chosen right after the probability the customer asked for sugar. So 18 out of 18 plus 11 plus 25, which is 54. 18 out of 54, which can equate to one third. 1/3. How? Okay. Again, there's 54 people that actually picked something, unless we're adding the 18 and 11. Yes, we have to add the 18 and 11. 18 plus 11, which is 29 over 54. I don't think that gives a fraction. Nope, 29 over 54. 29 over 54. So we just got it. 29 over 70. We have to add the 16? But they don't choose anything. Okay. Okay, so we know that. You know that now. We don't need to do it again. According to whether, okay. Find probably the customer asked for sugar, given that they asked for milk. So 11 out of 70. What? How? Wait, hold on, let me just say something in chat real quick. I don't know if it comes up. I do like a little, hold on. Oh, 12 viewers. 12 views, average view duration, 5 minutes. For the 2 people watching the stream, you know what? First, you're gonna stay for 5 minutes and go on ahead, you know what I mean? Okay, 18 plus 11, 29, 54. How is that wrong? Oh yeah, we have a video. Duh. Okay. Hold on. Gonna have to turn off the headphones now. It's getting to the point where it starts to hurt. Hello, 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 hello. Nice, okay. Hello. Hello. Okay, yeah, there we go. Nice. Now if we do this, God.
There are 140 pupils in a group who recently took 3 science tests. The Venn diagram shows which tests they passed out of physics, chemistry, and biology. One of the pupils who passed biology is selected at random. Find the probability the pupil also passed physics. Now, usually it says we're picking someone completely at random. So we're picking someone from all of the 140 students. But the difference here is that now we're only picking a student from those who studied biology. So this probability is going to be out of all the biology students that we're picking from. So we're therefore going to focus on this biology circle, and we can completely ignore the rest of the Venn diagram because we're only picking from these students here. Now, how many students are we picking from? 20 plus 11 plus 30 plus 7.
Doing that. Sugar. 11 plus 18, which is 29. over 54. Oh, wrong side. 29 over 54. 11 over 36. This is confusing as hell. Cooked. Graph y equals 3x, sketch below. To the graph y equals 2 sub of x. So choose which red line shows a sketch of y equals 2x compared to the black graph y equals 3x. I don't know any of these. Y equals minus sine x. Oh my god. 4 marks. Triangle. Area equals the half times base times height. Half times u is 10 centimeters. 95 or 105 equals base is a centimeter. Half 7.5 or 7.5 times length. So we do 210 divided by 7.5, which gets you length, which gets you 210. 28. So it'll be 28. Nice. Okay. Decide who is correct and give reason for his decision. So these answers: 5x. So 5 x squared plus 2x plus 4 equals 45. So she got x equals 1, or x equals minus 5. So then I'm getting 5x squared plus 4x, so 20x plus 20, 5x plus 20 minus 25 equals 0. Divide everything by 4. X squared plus, by 5, sorry. 4x minus 5 equals 0. 1, 5. X. So x plus 5. 1 minus 5. X squared plus 5x minus 1 x equals 0. No, it's 5. X plus 5 minus 1 x plus 5. X equals 1, x equals minus 5. Yeah, it's going to be Taylor. Taylor's correct. Positive and negative square root should be 9. Oh, there are 2 correct solutions. Oh! Then she says x plus... So I know you could do that. Then x plus 2 equals 3, or x plus 2 equals minus 3. I'm going to go Sasha. Taylor, sorry. Yep. Nope. Solve this equation algebraically. Give your answer. Correct the 2 decimal places. X squared 5x plus 3 equals 0. Correct. I have to put everything in the calculator. Alexa, what's the quadratic formula?
According to Wikipedia, in elementary algebra, the quadratic formula is a closed-form expression describing the solutions of a quadratic equation. Other ways of solving quadratic equations, such as completing the square, yield the same solutions.
What? Alexa, what's the quadratic equation for GCSE students?
I'm not quite sure how to help you with that.
Shut the fuck up. Minus 5 plus 5 squared minus 4 1 3 2 3. Always write stuff down, guys. Never. No, sorry. No minus 5. Minus plus square root minus 4 1 3 3 2 3. First one is 2 decimal places. Minus 0.23 equals. Darn it. Minus 1.43. Minus 0.0. 0.33 minus 1.43, which gets you, which is wrong. Sick, dude. Yeah, right. 4 AC. Didn't I do that? Is that correct? Minus B, minus 5, minus B squared, minus 4, 1 to 3, and 2 to 3. Isn't that it? And 2A, that's literally the same thing I wrote here. So why am I as incorrect? Let's go plus. Oh my god, my head is spiraling. Minus 5. Rewrite this again. Minus 5 plus minus 5 plus square root 5 squared plus minus 4a for AC, so which is 1, 3. And is it A? Is it 2A? It's 2. Oh, okay. I see where I went wrong. You see? Oh, wait. Time has finished. Great, so we don't even finish with the paper. And it's freaking 9:40. I was supposed to be finished 10 minutes ago anyway. Darn it, man. Did I set it so like you guys cannot chat? Alright, that's the end of the paper, guys. We got like what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 say 2, so we got like what, around 34 marks for that one, so it's like a grade 4 minimum. Yeah, but that's like considering we even completed the paper. You know what I mean? Like my goal is to try to get 70 on each one. Alright, so let's see. So average view duration now is actually 7 minutes, so for those 2 viewers, thank you so much. Arigato gozaimasu. Sorry, no. Arigato gozaimasu. I said it. We are live, which is good. Chat rate, yeah, no one's really, 1 concurrent viewer. How do I know? 9:40, it's still at 1. We have 12 views. Stream health, we are in very excellent stream health. Our top fans are not here, because why not? Okay. Wrong side. Okay. Alright, so like now, where am I? Alright, so now we're gonna have to do some chosen topics. I'm gonna just say bye-bye to the paper, because right now it's useless, because we weren't able to finish it in time. Most of the stuff we got correct, it's fine. Now we've got to do some targeted revision. So let's just move out of this way. Okay, let's... Alright. Oh yes, sequences, my worst enemy. I have to find sequences here. Really? There it is. Okay, sequences, fundamentals, type sequences. You know, I think we might switch to called maths. Corbett maths also, right? Corbett maths. Okay. These are worksheets. Sequences. Okay, so we only have these guys, which is nice. Is that it? Sequences and fractional sequences. Let's have a look at the textbook exercise. So there's fractional here. Okay. See. Oh, sec. So only have these guys. Let's try the rules. Missing term. Enter fractional things. Why is there like patterns maybe? Pattern. Only that. Okay, Math Genie. Oh, they look like they changed the UI. They did change the UI. No way. No way. They changed the UI? Ugh. Oh, you guys are not seeing this. Hold on. What is this? This is what... I just found out. Maths, of course. Alright, we are doing OCR. Question bank. Topic by topic questions. Worksheets. Oh. Now, where was this 6 months ago? Oh, it's the final day. What am I supposed to do? Lessons? Oh, it's got premium, guys. Don't worry. Grade 1. Sequences. Predicted. Foundation. So there's 8 questions. Hold on. So the sequence, see the first 5 forms. Okay. See the you can come to see every question in this topic. Alright. If it's okay, fine. Gotta sign in quickly. Continue with Google. No, I don't want to be notified by email. Alright, we're back. Okay, good evening. It's gonna let me. Oh, too late for that. Alright, question bank. GCSE maths, OCR. Just sequences, right? Okay, nth term of sequences. Not solid. All revision guide, flashcards, mock exam builder. Yo. Okay, this 10 out of 10. Shit. 9-2 on the C is predicted. I can practice this. I can see all the questions. Here the first 5 terms. What? Yo, what? Liz, what? Introduction to sequences. Different sequences. Text term rules. No. I know how to do all this. Nth term for arithmetic sequence, non-standard formula. Nth term for more complicated sequences. Human dominant or arithmetic, yes. Okay, so. Okay. Shut up. Go here. Alright. So to enter for you, the numerator and denominator arithmetic sequence to be found. So yes. Yes. Right, yes. Okay. So just general iterative. Oh yes, please. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want 18 questions on this then. So then we want also that 1, 2, 3, 4, 5, 6, 7, 8. So 9, 18. So 18. No, hold on. 1, 2, 3, 4, 5, 6, 7, 8 plus 9, so 17 questions. So we want 20 questions with interleaving. The system differentiate between sub-skills in your section, given the harder, easier question based on chain mastery, or interleaving between all skills in your section. Okay, so we need to do 20 questions. Just focus 20 questions on sequences. That way we'll be able to do master sequences that should take about 40 minutes per topic, and I want to do like what, 5 topics, so 5 times 4 is 5 times 40 is 20, 200 minutes. That'll take 3 hours plus, which would take us to 1 o'clock. Yes. Okay, interleaving, here we go. Shit, hold on, wait, I haven't actually... No, hold on, instead, actually. I would go on, just need to take a break, 5 minutes, I'll be back. Let me see what my family needs. Shit. I'm back. Hey, all right. Nice break there. We need to go. Oh, we got a new viewer. Get in. Yes. Is this which camera is it? Oh, it's that one. Get in. -1A, 1. Okay, here's back terms of the sequence. Question 1. -1, 8. 1/9. 5/11. So +1, +1, +1. N +2. N +2. Wrong, okay.
In this video, we're going to find the nth term formula for a more complicated sequence involving fractions. Now, if we look at the first 5 terms of this sequence here, can you see that we seem to have 2 separate sequences going on in the numerator and in the denominator? In the numerator, you can see, look, we've got 9, 13, 17, 21, 25. That seems to be going up by 4 each time, just the numerator, and the denominator is going up by 1 each time. So we seem to have 2 arithmetic sequences, as we call them. Arithmetic sequences is where we're adding or subtracting the same number each time. So let's find the nth term formula for each of the sequences in turn. If we have 9, 13, 17, 21, 25 like that, how do we find the nth term formula of that? Well, if it's going up by 4 each time, then remember, we just take that number, the 4, and put it on front of n. So if I just do a little table here, I'm going to start the formula with 4n. But what would the first term of 4n be? Well, the first term would be 4 times 1. If it's the first term, you put in 1. 4 times 1 is 4, but we don't have 4, we have 9. So we need to add an extra 5 to get the 4 to the 9. Then
Okay, so add 1 equal 2 times 1 is 2. 2. 2 minus 1 is 0, 1, 2. You have to add 3. So 2n plus 3.
let's check with the second term of the sequence. 4 times 2 for the second term is 8, plus 5 is 13, which is correct. The second term is 13. So that is the formula for the numerator. What about the denominator? 5, 6, 7, 8, 9. We can see it's going up by 1 each time. So if it's going up by 1 each time, we put that number 1 in front of n. So it's going to be 1n like that. Now, what would the first term of 1n be? 1 times 1 would be 1, but we actually have 5, so we need to add an extra 4 to correct it. Let's check the second term. 1 times 2 is 2, plus 4 is 6. That seems to be right. So this was the formula for the numerator, and this was the nth term formula for the denominator, and therefore our final formula is going to be 4n plus 5.
So that gives us 2n plus 3, 1n plus 7. We'll just add this. N minus 3. It goes up minus 1.98. Is it minus 8 first? No. If you have a minus next to that fraction, the entire thing goes minus, so instead of plus, you have to switch it. And that's the rule. Question 2. The first 5. This is the first 5 turns of sequence. 5, 6, 7, 6. What to do with my life? So +1, +1, +1, +1. So that'll be n plus 5, 1, 12, 18, 18, 24, 30, plus 6, plus 6, plus 6, 3 and squared equals 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27, 4 times 3 is 16 times 3 is 48. Because this is the World Cup. Hands up in the air. 22, 40, 94. Plus 7, plus 10, plus 13, plus 16. Guessing. 7, wait. Plus 7, plus 10. So 27 plus 13, 48. No, 16 times 3 is 48 indeed. So how do you get 94? 13 plus 16 because you get 64. It's going up in threes. 3, 12, 27, 48. Unless I've done my squared. 3 is 9, 4 is 16. 10, 22, 40, 64. Oh, 64, you idiot. Oh, no. Oh, no. It can be fixed, yeah. Just 64. Yeah, 16. So it goes up in 3. So 3n. So 3 to 7 plus 4. Shut up, doggy. There's a dog barking outside. So it's n plus 5 over 3n squared plus 3n plus 4. Because this is the World Cup. Yeah, you guys listen to New Astro Speed song. Pretty lit, ain't it? 3n plus 4. Plus 5 is 6. Oh, that'll be n plus 4. Surely now that's correct. Yes! Alright. Let's put in timer for 40 minutes, please.
40 minutes, starting now.
What a good girl, to be honest. Oh, yeah. Okay, question 3. The first 5 terms of sequence by considering numerators and denominators separately, find an expression in terms of n to sequence. 20, 80, 320, 1280, 5120. So what we done? We times that by 4. We times this by 4 as well. Times that by 4. Times by 4. Times by 4. I forgot what that would be. Would that be... Hold on. Okay. 10 to the power of 4. So then plus 19. So 1 power of 4 plus 19 is 20. 2, 35. No. Four times. Wait, how do you? Okay.
In this video, we're going to find the... So let's deal with the denominator. So what we need to do is we need to find the nth term formula for the numerator, and then the nth term formula for the denominator, and then put them together. So let's deal with the denominator first. Let's copy the sequence. We've got 13, 16, 19, 22, 25. We look at the differences first. So we saw that the difference was 3 each time. And if you have a simple sequence like this, which is going up or down by the same number each time, then you take that number, the 3, and just put it on front of an n term. So if I just put a little line here.
Yeah.
2 each time. That works. The second term would be 2 to the power of 2, which is 4, which indeed works.
Other way around.
So this does seem to be the correct. And
okay, got it. So it's 4 to the power of n, and then when you find the bottom one, which is 11, 14, 17, plus 3, 3n, plus 8. So it's going to be 4 to the power of n over 3n plus 8. Because this is the world. Put your hands up, India. 4 to the power of n, and 3n plus 8, 3n plus 8, so 1 times 3 plus 8 is 11, 2 times 3 plus 8 equals 14. Is it times by 4n? 20 times, yeah, it is times by 4. What's the power of n?
let's copy the sequence, which indeed works. So this does seem to be the correct formula here, and that was the correct formula for the denominator. So if you put the 2 together, divided by the, and that is the...
Isn't that not 4n? 4 to the power of n? And then 3n, and then how do you get from 3 to 11? You add 8. 3 times 2 plus 8, 14. Yeah, this is genuinely correct. I don't know why it's incorrect. How is this incorrect? 5 times 4n. So 4 to the power of 1 is 4. Oh, I see. Yeah, okay. Yeah. Guys, good thing that we got that wrong then. The first 5 terms of a cubic sequence: 7, 13, 31, 67, 227, 7, 13, 31, 67, 127. So 8, 31, 18, 67 minus 31. 36. $91. And then 7. $660. So 10. 18. 24. So plus 8, 4, and squared. 4, 16. 9 times 4 is 36. 16 times 4 is 64. And 9, 5, 25 times 4 is 'cause this is the World Cup. Put your hands up in the air. This is the World Cup. So 4 to 7, or 7 to 4. 7 to 4 is minus 3. Taking 6 is minus 3. They want to 36 is 7 to 4 minus 3, and then 13 is plus 3, and then minus 5? No, plus 5 plus minus 3 again, and minus 27. Minus 3 plus 5 minus 3 minus 27. 6 plus minus 3 plus 3 is 6. Then 3 plus 2. And 2 to minus 3. 2, 1, 0. Minus 2. Minus 1, 0, 1, 2. Then from plus 5 to minus 3 is minus 8. Oh, I'm so lost. Yeah, keep the sequence.
In this video, we're going to find the nth term formula of a cubic sequence. Now, with a quadratic sequence, we saw that the difference of the difference is fixed. But with a cubic sequence, you might guess it's the difference of the difference of the difference which is fixed. So the third difference, as we call it, is fixed. So let's just do what we'd usually do with a quadratic sequence. We're going to copy out the terms. And we're going to look at the differences between terms. We can see from 9 to 31, it's going up by 22. From 31 to 81, it's going up by 52. From 83 to 177, it's going up by 94. And from 177 to 325, it's going up by 148. And then if we find the difference, that's going up by 30. This is going up by 42. And then this is going up by 54. Now, if we look at the difference of the difference, this is going up by 12, and this is going up by 12 again. So it seems to be the difference of the difference of the difference, which is fixed. The third difference, as we call it, is fixed. Now, with a quadratic sequence, when we found the second difference, we halved it and put it on front of an n squared term. So what do we do if it's the third difference? Do we halve it and put it in front of an n cubed term? Well, actually, it turns out that you need to divide it by 6. So you divide the third difference by 6 and put it in front of an n cubed term. So 12 divided by 6 is 2, so it's going to be 2n cubed like that.
Please repeat that again.
So you divide the third difference by 6 and put it in front of an n cubed term. So 12 divided by 6 is 2, so it's going to be 2n cubed like that. And let's put this into a table. And you might wonder, where does the 6 come from? Well, if it's a third difference, you actually divide by 3 factorial. 3 factorial means 3 times 2 times 1, which is 6. If you've got the fourth difference is fixed, then you would divide it by 4 factorial, which is 4 times 3 times 2 times 1, which is 24. And then you'd have that number in front of an n to the 4 term. If it was the fifth difference which was fixed, you divide by 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120, and so on.
Okay.
And I'm not going to prove why that works in this video. And then what we do is we think, well, if the formula starts as 2n cubed, what would the sequence be? Well, 2 times 1 cubed is 27, is 54. 2 times 120.
Yeah, okay. And then, yeah, he gets that, 3n squared. Minus 1n, and that gets the answer. Okay. Try again. 7 plus... No, 7, 13, 31, 67, 127. So 7 to 13 is... add... Not 8, sorry. 6. 13 to... So 31 to 13, 31, 13... 18, and then 67 minus 31, we get 36, 36, and then 127 minus 67, which gets you 60. So plus, so this is the second difference. We need to find like 3 differences. Plus 12 plus 18. Yeah, plus 18 plus 14. No, 24. 24 plus 6 plus 6. So we divide by factorial of 6. Because 3 times 2 times 1. So that gets you n squared, which is a nice number. 1, 4, 9, 16, 25. The original sequence. 6, 18, 36. That's the wrong sequence. 7, 13, 31, 67, 127. So there's plus 6, 4 to 13 is plus 9, and 9 to 31 is 9, 31 minus 9, 22, plus 22, and then 16, 7 minus 16, which is 51, and then 127 minus 25, 102. Then, so plus 3, and then 22 minus 9 is 13. 29. New plus 10. Three, 13. Add plus 10, and then 13, 29 is plus 16. And 51 minus 29, 22. Which is plus 6, plus 6. What did he do at the end? 'Cause this is the
Cubed,
World Cup.
first term, -1 times 1 is -1, but we've actually got 4. So we need to add on an extra 5 to correct.
Then we have to half that. After we get that, so we half it. So we have actually 3n squared. Which is 327 plus 4 plus 3 plus 2. Hold on.
3 times 1 squared is 3. 3 times 2 squared, 3 times 4 is 12. 3 times 3 squared is 3 times 9, which is 27. That would do. And then we think, what do we need to do to the 3n squared sequence to get to this sequence here? With a 3, you have to add...
Oh, okay. So, 7... No. Oh, that's close. Because this is the World Cup. This is the second sequence, isn't it? So we're looking at the original sequence. Oh, wait, what? This is the World Cup.
That would do. And then we think, what do we need to do to the 3n squared sequence to get to this sequence here?
7 plus 15 plus 29 plus 49 plus 75. So that one. The second one is this one. 3, 13, 29, 51. 3, 13, 29. Because this is so 0 plus 1 plus 2.
With a 3, you have to add 4. The 12, you have to add 3. The 27, you have to add 2, etc. And then what is the formula for this sequence we just added here? Well, this is going down by 1 each time. And if it's a simple difference, just it's going down or up by the same number each time, we take that number, the -1, and we put it on front of an n term. So it's going to be -1n. And then we might need a correction here. -1n, what does that give us for the first term? -1 times 1 is -1, but we've actually got 4. So we need to add on an extra 5 to correct it.
Okay, so 1 times 1 is 1. 1 times 1 equals 1 plus... It's 1 plus... This is the World Cup. With hands up in the air, with hands up in the air. So, n times 0. So, 1 times 0. 3. 2 times 1 plus 3 equals... Confusing. N. So 1, 2, 3 plus 1, so n. N times 1, 13 equals plus 12 actually. N times 2, 1 times 2, 12 equals 2, 24. Why is it so weird? Why is it so hard? So yeah, 3, 12, 27, 48, and then we put underneath, and then +1, +1, +1, +1. How'd you get from 1 to 13? You plus 12, so n plus 12. Plus 12, yeah. Plus 6n squared plus six
Let's check. Gives us the correct sequence. And we can see, look, this sequence here is 2n cubed. This sequence here is 3n squared minus n plus 5. So it's this plus this, which gives us the correct formula for this original.
Alexa, how much time is left? Okay, so 17 minutes left. Okay, we haven't really made progress, have we? Really? Fourth question only out of what, 20? 6s cubed. Wrong side.
It's 3, so we're going to get 3n squared. Let's think what 3n squared is. 3 times 1 squared is 3. 3 times 2 squared, 3 times 4 is 12. 3 times 3 squared is 3 times 9, which is 27, plus this, which gives us the correct formula for this original sequence. So minus n plus 5, and that is...
Okay, so just everything plus together. Okay, so 6n to the power of 3 plus 6n, or that, plus n plus 12. I'm not surprised, I give up. N squared plus n minus n plus 7. What? Okay, ask Gemini to make more questions for me. Okay. Given the first term of 3, use as your formula xn plus 1 equals xn plus 5 to find the fourth term. Give the answer correct 3 decimal places. So, given a first term of 3, use it as your formula. So, 3? So the first term is 3, 4. That is so weird. Hold on. How's the video looking like?
In this skill, we're going to look at iterative processes. Now, if we had a sequence x, we could use x1 to refer to the first term of the sequence, x2 to refer to the second term, x3 to refer to the third term, and...
So, x1 equals 3. x3 plus 1 equals this, x5. Cause this is the world of love. 3 hands up in the air. 3 hands up in the air. I don't get this question.
2 to refer to the second term, x3 to refer to the third term, and so on. Is equal to 3 times the first term of the sequence. So the second term of the sequence is 3 times the first term, so it's 3 times x1, 3 times 2, which is equal to 6. So the second term of the sequence is equal to 6. Now, how do we work?
What?
And so what that's saying
One.
in words is that the second... How can we somehow use this expression here? What does that actually mean? Now, suppose in this, we let n be equal to 1. Now, what happens? Now, on the left-hand side, n plus 1 is 1 plus 1, which is 2. So we've got x2. So we've got x2, and that is equal to 3x1, because n is 1. So we've got 3x1. And so what that's saying in words is that the second term of the sequence is equal to 3 times the first term of the sequence. So the...
Oh, okay. Alright, so we do n equals 1. So n equals 1. And what do you do?
2, which is equal to...
x2, x2, which is equal to what? It doesn't tell us. We know x1 is something, but we know that... Hold on. No, wrong side. I just like xn plus 1. Oh, it's so weird. Xn plus 1, okay. We know the first term is 1, so x the first
2, which is equal to 6. So the second term of the sequence is equal to 6. Now, how would we work out the next term? Well, if n was 1 more than that, say 2, we would have x, and then 2 plus 1 is 3. So we've got x3 is equal to 3x2, because n is 2, 3x2, like this. So in words, that's saying that the third term of the sequence is equal to 3.
Oh, okay. So n equals 1. So n plus 1 is 2. So x to the power, so x to the power 2 is equal to 3x1. So x1 is 2. So it will be 4. 3x1. So the second term, okay, so the second term in the sequence is equal to timesing by 3 of the first sequence. So this is the first sequence. We have to times that by 3, and then we have to times that by 3, and times, okay. So what's this telling us here?
Equal to
xn plus 1 equals 3xn. xn plus 5. Which is x2. So the second term of the sequence is equal to the square root of the first sequence, square root of the first number plus 5. So square root of 3, I'm pretty sure.
equal to...
This guy has 3x and n. X, so the second term of the sequence, x equals 3x1. We ignore this then. That's just the second to the third term, don't we? That's just 3n then. So we do 3 plus 5, which is 8. So root 8, and then the second term would, so the first term is 3, second term is root 8, and then we have to do root 8 Although, oh, then we can like just do 4, can't we? So it went from 3, then it went to root 8. Three, 6, 9, 12. 12. So 12 plus 5, which is 17, which is 4.1231. This iterative sequence is really killing me.
Equal to 3 times the second term of the sequence. In this skill, we're going to look at iterative processes. Now, if we had a sequence x, we could use x1 to refer to the first term of the sequence, x2 to refer to the second term, x3 to refer to the third term, and so on. Now, it tells us the first term of this sequence is equal to 2, so we know this is equal to 2. But what about the other terms? How can we somehow use this expression here? What does that actually mean? Now, suppose in this, we let n be equal to 1. Now, what happens? Now, on the left-hand side, n plus 1 is 1 plus 1, which is 2. So we've got x2. So we've got x2, and that is equal to...
That's how it says on mine. X plus 1, so x2. So same as him.
n plus 1th term is equal to 3 times the nth term. Or in other words, each term is equal to... As the first term, we've got x2. So we've got x2, and that is equal to 3x1, because n is 1. So we've got 3x1. And so what that's saying in words is that the second term of the sequence is equal to 3 times the first term of the sequence. So the second term of the sequence is 3 times the first term, so it's 3 times x1, 3 times 2, which is equal to 6. So the second term of the sequence is equal to 6. And so what that's saying in words is that the second term of the sequence is equal to 3 times the first term of the sequence. So the second term of the sequence is 3 times the first term, so it's 3 times x1, 3 times 2, which is equal to 6. So the second term of the sequence is equal to 6. Now, how would we work out the next term? Well, if n was 1 more than that, so 2, we would have x, and then 2 plus 1 is 3. So we've got x3 is equal to 3x2, because n is 2, 3x2, like this. So in words, that's saying that the third term of the sequence is equal to 3 times the second term of the sequence.
Okay, I think I got it now. Okay, so what we need to do is x1, we already know it's 3. Then we gotta find x2. So x2 is equal to what's x? It gives me x, but I don't know what x is. Let's be very dumb.
So u3 is going to be 1 over the previous term, so the second term plus
that is the wrong video. Hello.
Second term plus 2. You had the nth term of the sequence. We know that the next term of the sequence would be xn plus 1, because this position is the second term of the sequence. So this third term here is 3 times the second term. 3 times 6 is 18.
So 2. So we put 2 in there. 3. Oh, that's just n there. 3 times by 2. No, we put the first term in. So 3. So root 8. So root 8. And then we have to do, yep, x3 by the third. No, that's the first term. We already know the first one's 3, and then this one's root 8, and then 3. So n equals 3 equals x4. So this is how to find the fourth one. x3. So my battery is plugged in. Hello. No, x3n. What am I doing? This is the World Cup. It's gonna be root 8 plus 5. Root 8 plus 5, which is equal to 2.7979. 2.7979. Whoa! What? How? I don't know. Alexa, show me the timers.
You have 2 minutes left on your 40-minute timer.
Cheers. Okay, so I just turned it off.
In this video, we're going to form some equations given a description of an iterative process. Now it says Miriam buys a house worth 200,000 and it is expected to increase in value by 5% each year. Complete the following iterative formula to calculate the value of the house, where Vn is the value of the house after n years. Now an iterative formula allows you to generate a sequence of values. So we have initial value of the sequence, and then we need some rule about how to get to the values of the sequence after. So let's say we had a sequence x, and let's just say that we said that x1 was equal to 4, and that's basically saying that the first term of the sequence x is 4. And then let's say we wrote xn plus 1 is equal to 3 times xn. Now what that's saying is that the n plus 1th term of the sequence is equal to 3 times the previous term of the sequence. So if we take the previous term, then the current term of the sequence will be this xn plus 1, the house, where Vn is the value of the house after n years. Now, an iterative formula allows you to generate a sequence of values. So we have initial value of the sequence, and then we need some rule about how to get to the values of the sequence after. So let's say we had a sequence x, and let's just say that we said that x1 was equal to 4, and that's basically saying that the first term of the sequence x is 4. And then let's say we wrote xn plus 1 is equal to 3 times xn. Now what that's saying is that the n plus 1th term of the sequence is equal to 3 times the previous term of the sequence. So if we take the previous term, then the current term of the sequence will be this xn plus 1. So this is basically saying that the current term of the sequence is 3 times the previous term. So if we know that the first term of the sequence, x1, is 4, then the sequence would start 4. And then it's saying the next term of the sequence is 3 times that term. So we times that by 3, you get 12. And then it's saying the next term of the sequence is 3 times the previous term. So we times by 3 again, you get 36. and so on. So this iterative formula allows us to generate this sequence. Now, in the question we've got, we're trying to generate a sequence for the value of the house after each year. So we need to come up with a similar formula to this. Now, V0 is going to be the value of the house after 0 years, because if Vn is the value after n years, V0 is the value after 0 years. So that's the initial value of the house. Now, we know that's a 200,000, so we know that V0 is 200,000. And now, can we think of a rule that allows us to get from the value of the house 1 year to the value of the house the year after? So Vn plus 1, the next value of the house, is going to be what in terms of the current value of the house, Vn? Well, it's saying the house is increasing in value by 5% each year. Now, what do you multiply something to increase it by 5%? Well, everything starts 100%, so if it goes up by 5%, it's going to be 105% of its value. And then you convert that to a decimal. So you just divide that by 100, 105% as a decimal is 1.05. So you times by 1.05 to increase something by 5%. And therefore, we're going to put a 1.05 here. And effectively, there's a times there. Because the next value of the house, the value after n plus 1 years, is going to be 1.05 times the previous value of the house, the value after n years. And that is a completed formula. Now, we don't need to write the times in algebra, so it's just one.
Okay, finally we get that quite correct. Okay, next, 7. Here formula uses un plus 1 equals aun minus 43 is used to generate the following terms. u4 equals 73, u5 equals 3 to determine the value of a. So let me write this down. Un plus 1 equals aun minus 43. So n equals 1. U1 plus 1. I still don't get it. I can't picture it. I can't. I genuinely can't. I don't know how.
In this video, we're going to find unknown constants in an iterative formula. Now, just as a reminder, an iterative formula is just a way to generate a sequence of values, where each term has a rule on how to generate the term from the previous value. Okay. So here, what this is saying is that the next term of the sequence, is equal to a times, we don't know what a is, the previous term of the sequence, un, or the current term of the sequence, plus the 21. So we can get to the next term of the sequence by doing a times the previous term plus 21. And it's saying that u2 is 10, so that means the second term of the sequence is 10, and u3 is equal to 1. So the third term of the sequence is 1. We've got to determine the value of a. Now, we've got 2 consecutive terms of the sequence here, and therefore they can follow this rule here. Because, for example, the third term of the sequence is a times the previous term, the second term, plus 21. So, for example, we could write u3 is equal to a times u2 plus 21. Because the third term is a times the second term, the previous term, plus 21. Now, we've got these 2 values here. So u2 is 10, so we can write a times 10. And we've got u3, which is 1. So we've got 1 is 10a plus 21. And now we've got an equation which we can solve. Now, we need to get rid of that 21 here. So I'm going to subtract 21 from both sides of the equation.
Okay.
1 minus 21 is minus 20. And on the right-hand side, we get rid of the 20.
Minus 2. Okay. Guess that is, to some extent, understandable. Just keep forgetting. I keep forgetting straight away how to do it. It's getting really annoying.
Minus 20. And on the right-hand side, we get rid of the...
So u3 equals, okay. So u5 equals au n minus 43. U5 equals a so U4 is just 23 minus 43. And U5 equals 3. So now we have 46 equals 23a, a equals 2. Lovely. Okay. Okay, find the answer of the sequence 636, 269. I'll give you answer in simplest form. We're not even halfway yet, by the way. 636, 216, 129, 6. 6, 36, 216, 1296. 6 times 216, 129. Okay, so it's times 6 times 6 times 6. It's going to be just 6n, I'm pretty sure. Shut up! 6 to the power of n. Nice. So this is the World Cup. Your hands up in the air. It's 14. Find the answer of the sequence. 98. 6, 8, 6. So plus 12. 98 plus 14. No. 84. Oh my god, these are some big numbers. 686 minus 98. 5, 8, 8. So we're not, yeah, we're definitely not adding. 2, 14, then 4 minus 12, 72, 588 minus 84, 504. In terms of the nth term for geometric sequence in the form of K-A-N for positive integers A. Geometric. How do you do geometric sequences? Oh no. There's like a certain thing with times and by. Are we times them by 7? Oh, we times by 7 each time. Oh. 2, 14, 98, 6, 8, 6, times 7, times 7, times 7, 7, and that's it, I think, right?
Hi, in this video, now let's compare that to this sequence here. Well, it's not the same, is it? This is 3, 9, 27, but the sequence we actually want is 5, 15, 45, 135.
What?
So let's write that sequence below, what we actually want. And then we're going to have to think about how we're going to correct this sequence, what we're going to do to this sequence, 3 to the power of n, to make
7.
it what we want. Now, can you see that there is just a kind of, we can scale it by the same number. So what's that scale factor there? Well, if, for example, you had, I don't know, 2 and 6 and you wanted to work out the scale factor, you would just do 6 divided by 2. So you can see you're dividing by 3. So we're scaling by 6 over 2, which is 3. So if 3 becomes 5, the scale factor is going to be 5 over 3 because we do the second number divided by the first number.
That's disgusting. I'll never do that again. Oh my god, what am I doing? Oh my god, I'm on live. Oh, what am I doing? Oh, I need... Okay, I need to stop doing that. 7, what? geometric sequence, and then the n. N, 3n, 1, 2, 3, 7, that's sorry. 7, 49, 3, 4, 3. The thing that we really want two, 14, 98.
And we can see actually it's the same thing here. We can times by 5 over 3, and 9 would become 15. The 27 we could times by 5 over 3, and we do get 45.
2e, so 2 over 7. 7 times 2 over 7, 2, 49, 14, 3, 4, 3, 98. Enough. 2 times 7, 2 times 7. No, 2 over 7.
So what does this 3 to the n become? If we times that also by 5 over 3, then we're just going to get 5 over 3 times by 3 to the n. So this is the correct sequence because look, you can see here it's 5, 15, 45, 5, 15, 45. The next one would be 135. And this formula will get us to there. Now, we could put that as the final answer. So if we want to put it in here, that is this, and that would be fine as a final answer. But if we want to go one step beyond that, we could actually simplify this. So here's what I'm going to do. I'm going to actually use the laws of indices because I could write this as 5 times by 3 to the n divided by 3 because I could just make that over 1. So I've turned that into a single fraction. Now, if I make that 3 as 3 to the power of 1, we could use laws of indices because...
I'm not simplifying it. We're just going to write the answer down. 2 over 7. Is it times or plus? No, it was plus, wasn't it? No, it's times.
Same, is it? This is 3, 9, 27, but the sequence we... When I have...
Times 7 power 10. Flying through these pages, by the way. Other questions, I think. We found the answer of the sequence. Minus 3, minus 18, minus 108, minus 648. So times by 6, and then 6 times 18, I'm guessing. Yep, okay. Times 6, times 6, times 6. And then n 1, 2, 3, 6, 36, 6 times 6, just 16. We have minus 3, minus 18, minus 108. Minus 3 divided by 6, minus a half, times by minus a half. So we do 36 times minus 0.5, minus 18. So we times by half. So the answer is minus a half. So 6n times minus a half. 6 to the power of n times by minus a half. So this is the World Cup. I hate that it's wrong. I hate it. Ugh. It's the same example. No, it's not. It's... Well, all terms are negative. Oh, it's probably different rule.
Hi, in this video we're going to see how we can come up with the nth term formula of a geometric sequence. So let's look at this sequence here. We're going from -5 to -10 to -20. Can you see there's a pattern in these numbers? Can you see that we could times each number by 2 to get the next number? So the numbers are doubling each time. And if we wanted the next number of the sequence, we'd times by 2 again. Now, we saw in previous videos that when that happened, we started our formula for this sequence as that number, 2, to the power of n. So 2 to the power of n. And remember, this 2 here, this number we're scaling by each time, is known as the common ratio. So whatever that common ratio is, in this case, the common ratio is 2, we do that common ratio to the power of n. And remember, n is just referring to the position in the sequence. So if n was 3, it means it would give us the third term of the sequence. If n was 5, it would give us the fifth term, etc. Now, what we do is we do a little table. That's how we did in the previous videos. So let's have a row at the top for n, which is a position. So when we're at the first term, n is 1, 2. You did the second divided by the first number to get the scale factor. 1 over 4 would also be multiplied.
Pardon?
5 divided by 2, you say we're timesing by -5 over 2, right? And
So it's the bottom number on top. Yeah, so
it's going to be the same number for these. So -10
mine's a half then.
the final answer in this box. I can combine it into a single fraction. So I'm going to get -5 times by 2 to the n over 2. And then we could actually
6n times 1 over -3 times 6 n minus 1. Is that what he got eventually?
first term of the sequence will be 2. If we want the second term, n is 2. And what
Oh,
in this video, we're going to see how we can come up with the n. And the third term will be 2 to the 3, which is 8, etc. Now, -5.
Oh, he gets it.
So I'm going to get -5 times by 2 to the n over 2. And then we could actually use laws of indices. If I make this 2 to the power of 1 at the bottom, then to use laws of indices, we're dividing the 2 to the n by 2 to the 1. We're dividing these two powers. And remember, when we divide two powers, we subtract the indices. So we subtract the n and we do n minus 1. So it's going to be 2 to the n minus 1. So we have -5 times by 2 to the n minus 1. And that is the final answer again, but it's a slightly better final answer than the one we had before. But that's the one I'm going to put in this box. So it's -5 times 2.
So -5 times 2n, and then he converts laws of indices.
2 to the n minus 1. And that is the final answer. N, and we do n minus 1. So it's going to be 2 to the n minus 1. So we have -5 times by 2 to the n minus 1. And that is the final answer again, but it's a slightly better final answer than the one we had before. But that's the one I'm going to put in this box. So it's -5 times 2 to the n minus 1. And that is the final answer.
Okay. 3 times 6 n minus 1. Because this is the World Cup. Question 11. Okay, found the answer of the sequence. 6 minus 36. 16 minus 1, 2, 9, 6. What's a 6 times -6 times -6 times -6 -6 that, and then n 1 2 3 -6 times what? -6 times 1 just -6 minus, that's just 36, then 36 times -6 minus 206. So 6, 36, 206. Okay. 3 times 6 n minus 1. 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 3 ti So we times it by minus 1. Minus 1. 6 over minus 6 minus 1. Okay. So n minus. So minus n times minus 6n. So minus n times minus 6 to the power of n. How is that not correct? Alright, we need to.
Hi, in this video, and this formula, so we don't need to do this in an exam, but it's just a test. 64? Yes, it is. Yes, it is. So it means that this.
And then what is it then? 6 times minus 6 and minus 1. Sum of minus 6. Term calculation value 6. So minus 6 that's 6. Yep. 6 times minus 6 and minus 1. Just slap an n minus 1 next to it then. Is that what we do? God's sake, I don't get it. Why is it n minus 1? Okay, find the nth term of the sequence. Oh, for God's sake. 0.5 minus 0.75. 1.125 minus 1.6875. 0.5 times 1.5 times minus 1.5. What? Minus 1.5. Minus 1.5. 1/3, so minus a third. Times minus 1.5 n. I've done it again. Idiot. And then 1.5n.
Hi, in this video is a 25th, and that is the final formula because this does give us the correct sequence.
Okay. Minus third times minus 1.5 to the power n. Put 5. Oh my god, 1.5, 1.5. The nth term is 0.5 times minus 1.5 minus 1.5 and minus 1. How do you guys get how is it 0.5? Okay, I see why. Yeah. This again. Okay, question 13. Root 5, 5, 5, 5, 25. So times by root 5 every time. Root 5. Okay, root 5n. Come on, I don't mind getting a reminder. Wow, that is.
Hi, in this video we're going to see how we can find the nth term expression of a geometric sequence. Now if we look at this sequence here, you might be able to spot a pattern, and the pattern is like what we're multiplying each time is always remaining the same. So if I'm going from root 5 to root 35, what am I timesing by? Now if we think about our laws of surds, if I
Root 7.
we do 5 show, and this the geometry that's our stop where sequence you want.
Difference.
Corrects it to give a second number divided by the first number, 6 factor.
So root 5 over root 7.
By root 5. When we times this by the root 5, but whatever that could. So I've got.
Okay, hold on. Let me get to that point first.
This is times by root 7. We can see that
10 by root 7
as the common ratio, right sequence. But let's see what that actually does. Now what I do is I do a little table, and I add a row at the top for n, where n is the position of the term of the sequence. So for example, if n was 1, we'd have the first term of the sequence. If n was 2, we'd have the second term of the sequence. This is the position. So let's just consider the first 3 terms. And now let's consider if our formula was root 7 to the power of n, what would be the first term? Well, if n was 1, we're going to do root 7 to the power of 1, which is root 7. If n was 2, we're going to have root 7 squared. Root 7 squared is root 7 times root 7 is just 7. And then if we had root 7 cubed, that's going to be 7 root 7, etc. But you can see that this is not the right sequence. We've got root 7, 7, and 7 root 7, but actually the sequence is root 5, root 35, etc. So what I'm going to do is on the next row, I'm going to write the actual target sequence. This is the sequence we actually want, 7 root 5, etc. So this is the target sequence, the sequence we actually want. And then what we did in previous videos is we have to identify how.
Just root 5. Root 5 power of n. Alright. Guys, this is going to be the last question, and then I'm going to have to end the stream because I got to sleep and try I wake up at like what, 7, so I can get 7 hours of sleep. Question 14. Common ratio of the geometric sequence. -3 minus 2 over y3 minus 4 3 y6. And the common ratio of geometry where the terms are expressed algebraically. Okay. So -3, and then we have to multiply that by some number. What? God. So I think we multiplied it by I don't know. 5p squared, 25p. What? You know what, chat? This is gonna be the end of the stream. I can't do this question. What? I'm tweaking.
Hi, in this final video on finding the nth term formula of geometric sequences, we're going to look at a sequence which has algebraic terms like this. So we've got the terms 5p squared as the first term, then 20p squared, then 80p squared. Can you see the pattern to this sequence? Now, can you see that actually each time the terms are getting 4 times bigger? So that's getting 4 times bigger, then that's getting 4 times bigger. And remember that we called this scale factor, if it remains the same, that's known as the common ratio.
Okay,
Common ratio.
I want to know.
And
it's -3, and then we multiplied that by 1.5.
such a sequence, which has a common ratio, is known as a geometric sequence or a geometric progression, as it's sometimes called. And remember what we did as to get the starting formula for our nth term formula for the sequence. If you have a common ratio, in this case 4, we started the formula with that number, so 4 to the power of n. So whatever that common ratio is, in this case 4, you make it that to the power of n. That's going to be the formula to get the nth term of our sequence. Now, what I always do is I then add an extra row above for n itself, where n is the position. So, for example, if you wanted the first term of the sequence, you'd make n1. If you wanted the second term of the sequence, you make n2. If you wanted the third term, you make n3. So let's see what we get for our terms of sequence. If n was 1, our first term is going to be 4 to the power of 1, which is 4. If n was 2, you're going to get 4 squared, which is 16. If n was 3, you're going to get 4 to the power of 3, which is 64, etc. But the problem is that that's not the correct sequence. Our sequence at the moment is 4, 16, 64, but we want 5p squared, 20p squared, 80p squared, etc. So by p squared, to get that p squared, 6.
504.
In various values of n, 1, 2, and 3, that would be squared 4 to the power of n minus 1. We subtract the indices.
So 5p 4 times 4, so 5p times 4 minus n minus 1. I just don't know what they multiply by. هلا ابوي السلام عليكم. ما زلت قاعد اسوي رياضيات. Let's have a look at Gemini, what he said. Geometric sequence can look intimidating when algebra gets thrown into the mix, but the core rule never changes. To find the common ratio, R, you just divide by the term right before it. So R equals term 2 divided by term 1. Let's break this down step by step using your sequence. Therefore, identify your terms. From the image, the first two terms of your sequence are term equals minus 3. It's not minus 3. It's minus 3. Okay. No, ChatGPT, fuck you. Sorry. So, set up the division. To find R, we divide term 2 by term 1. Okay, simplify the fraction. Divide a fraction by a whole number. Is that it is the same as multiplying the fraction's denominator by that number. Also, notice that negative divided by negative becomes a positive. So 2 becomes... Okay, that's a rule to know. Okay, so you do minus 2y3 over minus 3 is the same as y3 times minus 3, and it's negative still, over minus 2. And the entire fraction is negative, so like we do 2 y3 3 like that. Okay, so r equals 2. Double check, option helpful. We have to shoot, let's see if multiplying term 2 by our new common factor give us 10. Okay, term 3 multiply 2. Okay, multiply numerators for... Yeah, it's the same. Putting together, massive factor. So common ratio of the geometric sequence 2 to 3y. That. Two over 3. Oh. 2 over 3y power of 3. Cause this is the World Cup. Put your hands up in the air. Put your hands up. Okay. The first 5 terms of a sequence by considering the numerator and denominator separate, find an expression in terms of n. Let's see if we can remember how to do this now. 6, 10, 14 plus 4 plus 4 goes up in 4n. 4n, how do you get 4? 6 plus 2. 4n plus 2 over 7, 8, 9, n. You get from plus 1, so 1n plus 6. n plus 6. So do this. 4n plus 2 equals n plus 6. It is incorrect, so I'm gonna end stream. This is right. I'm not, because I'm not an idiot. If we get a question wrong, we fix that question and then we end stream. Here's the first 5 terms of a sequence, or unless I'm thinking like a pussy. I don't want to do it, but I don't know. Here the first 5 terms of sequence. I've had an expression in terms of n. Okay. 8, 8, 12, 15, 16, 24, 20, 35. So plus 4, 12 to 16 plus 4, plus 4. So 4n plus 4. Then 8 plus 7 plus 8 plus 5, 8, 7 plus 24 minus 15. 9. So that's just plus 2, n squared equals 1, 4, 9. Original sequence is 8, 15, 24, so 7, 11, 4 is 9. Seven, then 15 minus 4, 11, 24, 24 minus 9, 15 plus 4 plus 4, 4n, n squared plus 4n plus 3, we n squared, no, 4n plus 4 over n squared plus 4n plus 3. So we gotta do this, 4n plus 4, and then n squared plus 4n plus 3. Surely that's correct. Please. Yes. I'm looking through these now. I haven't got one incorrect yet. 7 and 4 and 10 formula of a sequence where at least one of the numerals is geometric. Okay. So goes up by 2. 2, 4, 6, 9, 12, 15. Wasn't 2n, 3n plus 6. 2n over 3n plus 6. 2n over 2n over 3n plus 6. 2, 4, 6, 9, 12, 15. 2, 4, 6 plus 2 plus 2, 2n okay, and then 9, 12, 15, 3n. 1 times 3 is 3, plus 6 is 9. 3n plus 6 is 9, bro. Come on. I'm not tweaking. I haven't looked. I'm back. Oh my god, this is tiring. Okay. 2, 4, 8, 16, 32, times 2, times 2, times 2, times 2. Will be 2 that. So it'll be 2n over 3n plus 6. 3n plus 6. Yeah, that's so correct. It's incorrect. Hello? Hello? So like you're really wasting my time here. It's really pissing me off. Don't make me refresh. There was an error submitting my answer. Oh my god. Okay. Okay, so let's repeat. What? Oh, I got it correct. Yay! Okay. Sick, dude. Question 18. Here's for cubic sequence. First 5 times of cubic sequence. Next question. Okay. 5, 25, 79, 185, 361. What do you mean by cubic? Cause this is the World Cup. 79 minus 5. $34. $18. Divided by 6, which is 3n cubed. Three 12 times 4, 8, 3, 6. So 2 times 3 is 9, and then 4 times 3 is 12, 36, 3, 9, 26. 27 times 3, 81. Ow. 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 Shut up. $96.81. Then what do we do with that? Which is
The 3n squared sequence to get to
so we got that divided by 6. So 1 times. How'd they get that? $81. 4 times 4 times 4 times 4. 4 times 4 times 4 times 3. 4 cubed times 3. 192. 27. 25. 111. 5 minus 27. 28. 5, 6, what is that number? 14, 56, 126.
This sequence here. And if it's a simple difference, just it's going down or up by the same number each time, we take that number, the -1, and we put it on front of an n term. So it's going to be -1n. And then we might need a correction here.
Oh. Wow. Then 126 lines. What? Cubic sequence. Dude. There we go. And you also help. There you go. Okay. Analyzing. Because you definitely require a few more steps in your response, but it's a foolproof method called the method of differences. Crack them open. So n term a and so this is the equation always. Of course, find the values of a, b, c, and d. Let's break it down step by step. Original terms 5, 27, 39, e.g. 24 minus 5. Yep. Second difference 54 minus 20 equals 34, and then the difference e.g. 52, 18. So you're adding 18 constantly. I think that's what I've done. Yep. And then you find the 3 coefficient. You divide by 3, so it's just 3, and then 3 and squared, 3, 1. 1 minus 2. Need remains equals 2, 1. Okay, find that. Oh, so b minus 1. Oh, okay. 3 squared plus, what did it say? Oh, 3n plus minus n squared. Minus n squared plus 2n plus 1 plus 2n plus 1. Wow. Okay, chat, it's going actually to be the end of stream here now, because it is now 11:30. I want to wake up at 6. That gives me, what, 7 hours and 20 minutes of sleep? 6 hours and 20 minutes of sleep. That is not good for my brain. We need more, so I'm just going to try and make just as much sleep as possible. Also, our math teachers giving out candy, not candy, sorry, breakfast in the morning. So, well, I hope you guys enjoyed. Not even enjoyed. Hope you guys like were productive with me. Thanks for my freaking 2 viewers. Let's go. Get in. Thank you so much. Enjoy your evening or good night. Bye bye.